Good morning, students. Today we are discussing about that module number 2, that is distance protection. Here we are going to discuss about the topics like effect of arc resistance on the performance of distance relays, effect of power surges on performance of distance relays. So let us discuss about that effect of arc resistance on the performance of distance relays. As we know that very clear how the distance relays will function, based upon that the distance from the fault location to the location of that relay, this length of the distance value, if it is less than that of the predetermined value, then the distance relay will function. As we seen the number of distance relays like impedance relay, admittance relay, Moore relay and angle impedance relay. Similar to all those relays, generally there is a problem in every relay, that is whenever that short circuit fault appears or takes place between the two conductors or between that conductor, especially at the pole end from one end side to another end side, there is a problem with resistance which has been added from one line to another line by the time of arc or by the time of short circuit. So if a flashover takes place from phase to phase or phase to ground, generally wherever that fault occurs, an arc resistance is introduced in the fault path. Due to this arc resistance, the amount of that impedance value or the amount of the resistance value which is greater than that of the predetermined value, then it gives that errors and it won't function that relay. So the arc resistance is appreciable at higher voltages, and the arc resistance does not shows any impact if the resistance are small and operating voltage is very higher. But the arc resistance is higher than the operating voltage is lower, means it shows some effect. And one more one, the arc resistance is added to the impedance of the line while we are measuring, and hence the resultant impedance which is seen by distance relays is increased. This is an error which has been takes place while arc is formed between the two lines, or where arc is formed between three lines, or while arc is formed from line to ground. By that time the amount of the impedance which has been calculated in the impedance relay, or the amount of the resistance which was calculated, or the amount of conductance what we are calculated, does not give that appreciable results. It will fail that function. So in order to overcome this kind of errors, especially in case of distance relays, here the problem is with arc and the amount of the resistance which has been added to the existence conductor. So in case of ground faults, the resistance of earth is introduced into the fault path. The earth resistance includes that resistance of the tower footing resistance and earth return path. And also earth resistance and arc resistance combined together are known as fault resistance. So whenever the fault resistance takes place, the distance relays won't function in an appreciable way. So to overcome this difficulty, here we are discuss about that arc resistance and how it shows an impact in the performance of the distance relays. This is that impact of that resistance which has been added to the existence conductor from the another conductor, or from the earth to the existing conductor. By this here, the amount of the resistance or impedance which is greater than the predetermined value, then the relay won't function. So to overcome this difficulty, definitely there is a need to limit that arc resistance, and the performance of the distance relays has to improve. Next, our next topic is effect of power surges or power swings on performance of distance relays. So the below figure what I am showing here consists of a two generating stations at left hand side and at right hand side. Let us say that generating station A is going to generate a voltage A, and having a one more generating station B which generates a voltage EB. And here the two boxes here represented the two relays, and here Center of that there is a line which is called as transmission line. Here this line is going to protected with the help of these two relays, and relay A to generating station A, there is an amount of the transmission line whose impedance is called as ZA, and relay B to and generating station B, there is an amount of transmission line whose impedance is ZB, and in between there is a transmission line whose impedance is ZL. Now here the amount of the transmission line between the two relays, that is nothing but unit protection, which has been protected with a distance relay here, with the two distance relays which has been placed at either sides of the generating stations, which restricts that faults and fault currents, and has been protected that important unit of that system. Hence it is called as unit protection system. So in unit protection system, how the effect of power surges has been takes place, and how it will shows that impact on the performance of the distance relays. So if you see that the performance of the distance relays, how it will differ here we are showing that operating characteristics due to the power surges. So the operating characteristics due to the power surges, for example, if the operating characteristics lies within this circle, then only the relay will protect. And the operating characteristics here we are going to look at with respect to the reactance of the transmission line, and the admittance of the transmission line, and the resistance of the transmission line. So with respect to the reactance of the transmission line, admittance of the transmission line, and resistance of the transmission line, here we are going to provide that unit protection with respect to the Z. If Z value is, if the amount of impedance value, the amount of reactance value, and the amount of resistance value, if it is less than that of that predetermined value, then automatically it will protect, otherwise it won't protect. So by this way, if these characteristics lies within this circle, then it protects that relay, otherwise it won't protect. So the impedance relay characteristics and reactance relay characteristics are linear here, and within these characteristics of this circle, if it offers, then it will start that protection, otherwise it won't protect. Next, power swing analysis. So here to discuss about the power swing analysis, here I am showing that a two mission model system. In two mission model system consists of a generating station A and generating station B with a generated voltage EA and EB, and the amount of impedance ZA from station A and ZB is from station B up to that location of the two relays, and between the two relays there is a transmission line and whose impedance is ZL. So for analysis purpose here, we are showing that a two mission system with generating stations at either end of the line section having the generated stations whose voltage like EA and EB, and there is a relay location especially at the middle of the transmission line. And now the current which is flowing in this line, that I is nothing but the potential difference between the two generating stations from EA to EB to its overall impedance. The overall impedance of the transmission line here it is ZA plus ZL plus ZB. Here current is flowing from either ends, either from EA to EB or EB to EA. For suppose if the overall impedance of the transmission line, I can consider it as ZT, that is nothing but sum of ZA plus ZL plus ZB. I can replace ZA plus ZL plus ZB with ZT. Therefore from here we got the formula. If I assign that ZT to that side, that means if I assign ZT to that side, left hand side, here I into ZT can become as V. Therefore V is equal EA and minus I into ZA. EB means we can rewrite it as I into ZA. Now the impedance seen by the relay is given by Z is equal V by I. Here V means I can write that EA minus I into ZA divided by IA. And here IA is get cancelled, and remaining here we can write that EA by I minus ZA. And once again here if we do that simplification, here this equation can become as, that is EA into ZT divided by I means we can write that EA minus ZB divided by ZT. That means here I am substituting that in the place of I, if I am substituting that EA minus EB divided by ZT, the simplified equation can become as EA into ZT divided by EA minus EB minus ZA. This is that overall equation, simplified equation for the current or the amount of impedance which has been vary due to the effect of power surges either has been takes place at either ends. Thank you.